So for sway mechanism using moment distribution analysis, let us take this type of ABCD, and with loading UDL 30 kilonewton over here, 10 meter, 5 meter, a load acting at this joint B, which gives the sway effect. That is, the frame will now shift somehow like this. So this is sway effect. But the point is that the sway effect is due to the shifting of column rather than the beam. So for such effect to be restricted, a support at point C is to be developed. So steps involved. First is calculation of fixed end moments, which is also known as FEM. So FEM is to be calculated for each member, and in this type of question, if we see, this is a fixed support, this is a fixed support, and the support or the member between the supports are known as intermediate members or intermediate supports. For example, AB, BC and CD are intermediate support. So first we will calculate fixed end moment. So FEM AB, there is no load acting on member AB, the only load acting is at point or joint B. So this is not included for calculation of fixed end moment, because the load at joints or support do not induce fixed end moment, so it is equal to 0. So will be BA member, because there is no load acting in this member too. Fixed end moment for BC, there is a UDL, uniformly distributed load. So for this formula is WL square by 12. One thing to be noted, minus sign, because it will be acting anti-clockwise. We are moving from B to C, so the load will be acting in this direction, so it will be anti-clockwise. On calculation, we get this as minus 30 into 10 square by 12 is equal to minus 250 kilonewton meter. FEM BCB. Now if we see, this load will now act clockwise, so induce moment clockwise, and it will be equal to the magnitude of BC, but the sign will be different. FEM CD, this will be 0 because there is no load acting in this member, so will be DC. Now the first step of moment distribution analysis is completed. Now second step is calculation or computation of distribution factor. So for computation or calculation of distribution factor, let me draw a table, and the table will be made for B and C joint, because this is the joint for all member BA, BC, CD. So joints BC, member BA, okay, and BC, so will be CB, CD. We'll calculate stiffness K for each member, relative stiffness. For fixed end support and intermediate support, it is equal to I by L, and for extreme support internal hinge it is equal to 3 by 4 I by L. Okay. So if we see here, BA, for BA member it is a intermediate support, so it will be as I by L, and the length is 10 meter and I is equal to 2I, so 2I by 10. For BC it is also intermediate member, so it becomes 2I by 10. For CB 2I by 10, and finally for DC it is equal to, or CD is equal to 2I by 10. Okay. Summation of K, this is taken for each joint, okay, and it is equal to 2 by 2 5, 1 by 5 1 by 5, so it becomes 1 by 5 into 2, so it becomes 2 by 5 I, and same will be here 2 by 5 I. Now distribution factor, which is equal to K by summation K. Okay, can we calculate here? Now calculate for each, then we get 0.5 0.5 0.5 0.5. just put the value like 2I by 10 divided by 2 by 5, so we'll get 0.5 for this member, 0.5 for this member, and for this members. And to check whether the distribution factor is correct or not, the sum of distribution factor for a joint should be equal to 1, and in this case it is equal to 1, so this distribution is correct. Second step is completed. Now we'll go for the third step, that is calculation or moment distribution table. Now moment distribution table. Relative stiffness, which is I by L. So I will go through this question also. Relative stiffness I by L for AB, as I have already discussed, this is a fixed support, so relative stiffness will be equal to I by L, that is 2I by 10, because for this member I is equal to 2I. So for this 2I by 10, 2I by 10, 2I by 10, 2I by 10, 2I by 10. Now distribution factor, which is already calculated, 0.5. Now for AB, as I have said, this is a fixed support, so it doesn't contribute or does not play any role in distribution of the moment, so this becomes 0, that is dash. This is 0.5, 0.5, 0.5, 0.5, and again DC, it is a fixed end, so 0.5, so this came from the calculation of distribution factor. Now fixed end moments, which we have calculated in the first step, this is 0, 0, minus 250, 250, 0, and again 0. Are you getting this? This is the real part. Now we have to go for the balancing and carryover part. So before starting that, let me clarify you that carryover, COF, carryover factor, this also goes differently with these three kind of supports. For fixed end and intermediate support, the carryover factor is different, and for extreme support it is different. Because if we see a member like this is fixed end support, these are the intermediate members, and this is extreme support. So fixed end support doesn't contribute any for the balancing of the load, rather it takes all from the member. So it takes all from the member. In intermediate support there is distribution mutually, and it is equal to half of the load, generally half. And finally for extreme support, it is not capable of holding or resisting moment, so it doesn't take any moment, rather it gives all moment to the member. So this is the fundamental basics of carryover. Now balance, we have to balance this load. So for BA BC, I would like to just separate out this BA for B joint and for C joint. The load acting at point B, the moment at joint B is minus 250 plus 0 from left and right. So this is equal to minus 250. Minus 250 plus 0. This is minus 250. Now you have to balance this load. So which portion of or which member takes how much of moment and which needs the magnitude of moment to balance is given by the distribution factor. That is the 250 is the load moment at point B, and this has to be balanced, and some part of the moment will be balanced by portion BA and some part of the moment will be balanced by portion BC. That depends upon the distribution factor of respective member. So for BA, 250 into 0.5, this becomes 125 minus 125. As the overall moment at point B is minus 250, this has to be balanced by positive 125. Okay, plus 125. So will be the member BC plus 125, because the distribution factor is also 0.5. And in case of A, is there any moment that has to be balanced? No, because we cannot determine how much moment is at the joint at the point A, because it is a fixed end support, it will have some moment. So fill the box with the dash. For portion C, for joint C, the moment is 250, but it is positive, and the distribution factor is same as joint B, so it will become minus 125 minus 125, and D is a fixed end support, so it becomes dash. Carryover. Now there is a simple rule for determining the carryover factor. The simple rule is that there has to be made a crossing of the values between the corresponding members, that is AB, BA, BC, CB, CD, DC, and DE, ED, something like that. So, but by dividing by 2, because B is a intermediate support, and as I have said, in intermediate support there is a mutual distribution or for balancing of loads. So 125 divided by 125 divided by 2, this becomes 62.5 with the sign as it is, 62.5. okay, and this becomes dash again. Now cross multiply over here again, it will become minus 62.5 dash minus 62.5. okay, any queries up to here? No. Now the same process will be repeated till a very less decimal error is obtained. Or okay, so again start with balance. Now which load has to be balanced? This load has to be balanced, and I have already said at point A this is a fixed end support, so it cannot be balanced because we don't know how much of the moment is yielded at that point A. And the moment at point B now is minus 62.5 plus dash, that is 0. So minus 62.5 plus 0 multiply by the distribution factor of that member, we get 31.25. Please be careful with this sign. This is negative, then it should be positive to balance. So will be here. In this way we can complete this table. Okay, so after calculation of all balancing and carryover, a table like this will be obtained, and make sure that you end this table with the balancing row, and the digit must be very less for getting accurate result. So it should be less than 0.01. okay, that will be a better thing. And the last step in this table is to calculate the total, okay, summation, and we have to calculate from fixed end moment only, not this df. Okay, you have to eliminate this while calculating the sum. 0 plus 62.5 plus 52.625 plus 3.906, we have to calculate all this column, and then we get 83.328. Similarly 125 plus 31.25 plus 7.812 plus 1.953 plus 0.488 plus 1.22 plus 0.031008, we get 166.664. so 166.664, the value for this will come as minus 166.664, and again this will come as plus 166.664 minus 166.664, and finally 83.328. So this is the final result from the moment distribution table. If SOE mechanism is not considered, then we are just one step away from the final solution. That is, this is the total final moment. Okay, and with this moment we can draw the BMD, and that is the final result we are looking for. But for SOE, and with consideration of SOE effect or SOE analysis, one more step is to be done. Okay, so up to here I guess we don't have any problem. Now, as I have already discussed, that the effect of SOE is due to the shifting of column, okay, displacement of column, not of the beam. So while considering SOE effect, I would like to draw the column only. We can just put over here the moment that we have achieved. Okay, so clockwise moment 83.328, clockwise moment 166.664 BA CD. This is for AB, this is for BA, this is for BC. I didn't write for BC because we are not considering the beam over here, so I am considering only column. So BC positive 166.64. Now at point C, CB is not considered but CD is considered, so it becomes anti-clockwise 166.664, and at point D again anti-clockwise 83.328. This is the moment generated in AB and CD. respectively. Now I have to calculate the reaction over here, the next step. Okay, the next step is I have to calculate reaction RAX and RDX. We can consider any side direction. Now taking moment about B, considering this left part only, I get RAX clockwise, the distance is 10 meter plus 83.328 because clockwise, and 166.664, that is also clockwise. I get RAX is equal to 83.328 plus 166.664 is equal to divided by 10, 24.9, that is nearly equal to 25 kilonewton, but with a minus sign. That is, our assumption is wrong and the load will be acting in this direction. Similarly, taking moment about MC is equal to 0, considering clockwise as positive, we get RDX multiply by anti-clockwise, so minus RDX into 5 minus 83.328 minus 166.664 is equal to 0. Finally RDX is computed, 83.328 plus 166.664 divided by 5, I guess. Yo, we get 49.99. So this is nearly equal to 50 kilonewton. Okay, and the direction we assumed is wrong, so 50 kilonewton in this direction will be acting. Now the reactions have been, because we are calculating this reaction because due to this sway mechanism, it is caused due to the horizontal force. Now if we see the given question, a load was acting over here as 50 kilonewton. Okay, and we have computed 25 kilonewton in this direction. RDX is calculated as 50. Now for balancing, 25, 50, 75, 50, that gives us 25 kilonewton in this direction. Okay, so summation Fx, before that just this was a pictorial view, now we have to go through the equation also. Summation Fx, 25 plus 50 minus 50 minus x is equal to 0, x is equal to 25 kilonewton. As I have already said, a force of x kilonewton is to be acted over here to resist the sway mechanism. Now sway calculation, another step is sway calculation. This is the frame, it will somehow go like this with a deflection delta, B, B dash, C, C dash, A, B, 5 meter, 10 meter. Okay, sway calculation, A, B, C, D, sorry, A, B, C, D. Now MBA is equal to minus 6E 2I delta 10 square. The formula is 6EI delta L square. Okay, now the I for BA portion is 2I, so 2I delta E 610 square. Now we can calculate this, and this will be equal for MAB portion. Similarly MCD is equal to minus 6EI delta L square, that is 5 square, so it becomes is equal to MDC. Up to here no problem, I guess. MBA MCD we get. Now we have to assume the value of delta such that more precise result is obtained. The greater value we choose for delta, the more precise result will be achieved. Okay, that is EI delta. But for easiness we will consider 100, and it becomes as, let EI delta is equal to 100. Then we can calculate this value. Okay, minus 6 into 100 into 2 divided by 10 square. We get MBA is equal to MAB as 12 kilonewton meter, and MCD is equal to MDC is equal to 24 kilonewton, minus 24 kilonewton. Okay, so minus 12 and minus 24, these are the fixed end moment again, because we have to construct another fixed end, that is distribution table, moment distribution table. So up to here, any queries? Make sure this suggests us that MBC is equal to MCB is equal to 0, because for SOE analysis the beam portion is not considered, so the moment is not generated. So now we will draw moment distribution table for SOE analysis. Relative stiffness will be same, distribution factor will be the same, that is for. Now the difference will be here, because as we said BC and CB are the beam portion, so it will not induce any moment, so write this as 0. But the moment has been induced in BA portion, AB portion, CD and DC. So minus 12, minus 12, minus 24, minus 24. Again balancing is done in the same manner. This will be dash because it is a fixed end support. Minus 12 plus 0, this gives us plus 6. I am going verbally now, because minus 12 plus 0 is equal to minus 12, and minus 12 into 0.5 is equal to 6. The sign has to be negative, or we should be opposite to the total moment induced at that joint. Plus 6 plus 12 plus, sorry, yeah, plus 12 plus 12, and this again dash. So carry over, same, this will be 3, this will be dash, this will be 6, this will be 3, this will be dash again, and this will be 12, sorry, this will be 6. Okay, so similarly the table goes on. Okay, so this will be the completion of the table. Please take now we have to calculate the final moments here, that is summation. Minus 9, 10.5, 19, so it becomes minus 10.41. This is equal to 7.5 plus 8.78 and 12.79, 12.80, 18.43. This can be nearly written as 12.80. Okay, so these are the total moment or final moments. Now we can, again we have to make a figure like this, that is balancing or to represent the moment developed. Now with this value, again as I have said, beam portion is not to be included. Minus 10.41, this is anti-clockwise at point A. 10.41, 8.75, this means 7.8, 8.8. okay, this is BC part, that is beam portion still not included. CB also not included. CD 12.8 clockwise, so 12.80. sorry, it has to be negative. Anti-clockwise 12.80 because minus 24, sorry, I beg your pardon. Now 18.43, that is also anti-clockwise, I guess, yes, minus 18.43 at DCBA. Now again we have to calculate horizontal reactions RAX dash RDX dash. okay, that is summation MB, considering the left part only, is equal to 0 plus RAX dash multiply by 10 because the distance is 10 meter and 5 meter plus minus 8.8 plus 10.41 minus 10.41 is equal to 0. RAX dash is equal to 10.41 plus 8.8 divided by 10 minus 1.921, that is the direction assumed is wrong, so it becomes in this direction to be correct. So this is, so RAX dash is calculated. Similarly MC is equal to 0. We can calculate RDX dash, that will be equal to anti-clockwise, so 18.43 plus 12.80 divided by 5. 18.43 plus 12.8 divided by 5, 6.246 kilonewton. Now a general idea to be considered is (1.92) 6.24. (8.16) or not. Okay, so this is the general idea that has to be taken from this part, because 6.24 1.92 acting in same direction, that means it will be 6.24 plus 1.92. exact amount of this load should be acted in different direction. So x dash is equal to 8.16, that is summation fx is equal to 0, taking positive this, minus 1.92 minus 6.24. if I assume x in this direction, this will be also negative, is equal to 0, but it comes as 8.16 in this direction, x dash. Then x plus lambda x dash is equal to 0, or we have two different way of analyzing in this particular question, because this is without the consideration of sway effect, this is with the consideration of sway effect, the effect that has been developed due to the 50 kilonewton load acting from this direction. So x is equal to 25 plus lambda 8.16 multiplied by the direction of these two loads are different, so minus, then lambda is equal to 3.061 lambda is a constant. Okay, now the moment induced in each member MCDC is calculated. You have to be sure that the effect of both without non-sway mechanism and sway mechanism is to be taken. That is, if we see this part, in this table, the total moment in AB portion is 83.328 plus, if we see the moment, total moment in portion AB of sway mechanism is minus 10.41, which has to be calculated with 3.061 to get the final moment at that point, at that member. So this is equal to 51.475. Similarly, 166.67 plus 3.06 multiply by minus 8.8 is equal to 139.742 kilonewton meter. Similarly, for MBC, we have to take this value, and we get minus 139.742 kilonewton meter. 200 MCB is equal to 205.838 kilonewton. MGC also be calculated similarly. So in this way, the sway mechanism is considered for calculation of the moment using moment distribution analysis. So I hope you have understood this part. Please do subscribe and like for further any, and you can just comment down the problem if you have any.